Welcome back to another Vespa tutorial. In this tutorial I'm going to give you the sort of 20,000 feet overview of the analysis component. We're going to download some tutorial data from the Vespa website, load it into analysis, and quickly go through the different tabs and options just so you get an idea of what the program can actually do. So we're going to get started by loading the tutorial data from the Vespa website. So I'm going to open my web browser and navigate to the Vespa website. In the Vespa website, I'm going to go to Analysis right here, click on it. And in Analysis, first of all, you have the user manual, which I recommend reading. You can just open it with your favorite PDF reader. And you can see that this is version 0.7.3. You can see that if you go all the way to the appendix actually walks you through the tutorials on the website. So I'm just going to open the 6 tutorial dataset and use that, but you're encouraged to go through all 6 tutorials, A1, A2, A3, A4, A5, A6. Alright, going back, I'm going to close this PDF. And here there's a link to download the tutorials themselves. This is just a zip file. I'm going to click on it. This is the tutorial page, and here's the zip file with the tutorial data. Just click on it and save the file to your desktop. I can just put it here. This is my desktop. Close my web browser. And here are the tutorial files. You can unzip them anywhere you want. I'm just going to put them on the desktop for easier reference. If you open the folder, you'll see the 6 tutorials with their files, each of them dedicated to a different part of Vespa. We're going to use the data from tutorial 6 over here. So let's delve into it. Having downloaded the tutorial data, we're going to load it into Vespa Analysis. I'm going to open the command line, navigate to the Vespa directory where I've installed Vespa, go to Analysis, go to Source, and type python main.y. This will bring up the main Vespa window. Going to File, going to Open, and navigate to the desktop, Tutorial Analysis, Tutorial 6, and press CP0. This is going to be single voxel data from a press experiment with an echo time of 26 milliseconds. And I'm going to click Open. And within a few seconds, I get the loaded dataset. Vespa has 3 tabs here at the bottom called Raw, Spectral, and Fitting. Each of them deals with a different part of processing the data. I'm going to walk you through all 3 of them now. Let's start by looking at the Raw tab down here. I'll click it, and this brings up the header information stored in the file. Now what's exactly in the header will depend on what's in the header of the imported or loaded file, and it will contain information such as patient name, patient ID, measurement information, for example, how many averages were taken, in this case what the echo time was, 26 milliseconds, the flip angle, the frequency, here shown to be 63 megahertz, meaning that we are operating on a 1.5 Tesla magnet, and so forth. Having covered the Raw tab, let's move on to the Spectral tab. It's down here. I'm going to click it. The Spectral tab lets you spectrally process your data before moving on to fitting. So you see you can do phasing here, DC offset correction, left shifting your FID, zero filling, apodization. There's a signal filtering option here, usually used to filter the water. There's an option to do eddy current correction, and you can select either to FFT your data or not. You can chop, which corresponds to FFT shift in MATLAB, which sort of just switches the two quadrants of your data. And you can flip the x-axis. The view menu here lets you turn on or off the zero line. Now it's turned on, I'm going to turn it off. And the zero line usually is a useful thing to have just to see where the zero of your data is. I've turned it back on. It's this line, this straight line here. You can also turn on the x-axis, currently on and in ppm. I'm going to turn it off and back on. You can also choose what to look at, so the data type can be set to real, imaginary, magnitude, for example. I'm going to go back to real. I'll just draw your attention to the SVD filter parameters tab here. You see that the current signal filtering here is set to SVD filter. Going to the SVD filter tab, we obtain three plots. The top plot shows the original data. The plot here in the middle shows the components selected from the SVD filter. And the bottom plot here is the difference between the top plot and the middle plot. Here in this box, on the left side, you see all of the frequency components the SVD filter found. So each component has a frequency in ppm and hertz, a damping coefficient, a phase, and an area. And I can select different components and they will be subtracted from the spectrum. So you see, for example, all of these components in the middle, which have been selected and filtered out by the SVD filter, don't appear in the final spectrum. Now, these four components probably correspond to the water. These are actually three components because they're around 4.7 ppm. And indeed, if you look at the large water peak here in the original data set, it's almost completely gone from the subtracted data set over here. I can zoom in and you can take a better look. Let's go back to the General Parameters tab. Before moving on to the Fitting tab, I'd like to show you how to interact with your data. If you hold down your left mouse button and drag, you can zoom in. Double left clicking lets you zoom back out. I'm going to zoom back in here. Holding down the right mouse button and dragging lets you select an area, and here at the bottom right you can see the integral over the area as well as the root mean square. For example, suppose you're interested in knowing what the RMS of your noise is. You can zoom out by double left clicking and then select an area that looks like noise. And here you can get an estimate for the RMS of the noise. The scroll wheel lets you scale the plot vertically. If you hold down the scroll wheel, you can manually phase by moving the mouse either up and down to do 0th order phasing, or left and right to do 1st order phasing. You can also do automatic phasing found at the bottom left. One last thing before we move on. I can load another dataset, and I'm going to load the same dataset, so we'll have the same dataset twice. And you see that they open up here in two tabs, dataset 1 and here it's called dataset 3. They're the same dataset. The first one has been slightly phased differently because we just played around with the phasing, with the manual phasing. But looking at the first dataset, we can choose plot B here to view both datasets side by side. The top plot corresponds to dataset 1, the middle plot corresponds to dataset 3, and the bottom plot corresponds to their difference. For example, I can hold down my scroll wheel and phase the first dataset, and you'll see that interactively their difference starts deviating from 0. So even though they're the same dataset, the first one is phased differently. Finally, we take a look at the Fitting tab. The Fitting tab has multiple sub-tabs on the top here: metabolites, initial values, baseline, optimize, quality, and results. Each of them has many sub-parameters, and we won't be able to go through all of them. So I'll just quickly let you know what you're seeing and what the different tabs mean. First of all, on the right here, you see 4 plots. And these plots can show different things simultaneously. There are 4 menus here called Plot A, Plot B, Plot C, and Plot D, where you can select what exactly you want to see it in each of these plots. So for example, the topmost plot, Plot A, you can go to Plot Type, and you see that currently what you're plotting is the raw data, and on it superimposed your initial guess. Plot B currently shows the raw data and the chosen baseline. Plot C shows the raw data and on it superimposed the fit plus base, and plot D shows the raw minus the fit and the base. Obviously, if you have a good fit, this should be 0 ideally, or noise in reality. Now, changing one plot using the mouse buttons, for example, zooming in, zooms in on all 4 plots. So for example, you can see here in the second plot the baseline shown in purple. I'm going to click Fit the Spectrum just, and this will take a few seconds. And here's our fitted result. First of all, you see that the residual is very small, which is very good. Here you can see the raw data in black, and on it superimposed our model fit in green. And you see that they almost completely coincide. Let's take a look at some of the tabs here. The Metabolites tab lets you select which metabolites in your model you actually want to fit. And you can generate these models, these basis sets, these metabolites, either by using the simulation tool or creating a database of peaks manually in an XML file. The Initial Values tab helps you determine which initial guesses you're going to start out with. So this will affect how fast your fitting converges, and sometimes whether it converges at all. The Baseline tab tells you, or tells actually Analysis, how to handle the baseline, meaning everything that isn't fitted by the metabolites over here. So you can choose to model the baseline using wavelets or splines. The Optimize tab helps you fine-tune the algorithm, and basically the heart of analysis. Quality lets you calculate Kramer-Rao lower bounds on the fit, as well as confidence intervals. And finally, Results gives you the fitted results. You get results for the area, including Kramer-Rao bounds and confidence intervals, as well as results from the fitting for the frequency of each of the metabolites. We'll delve in more detail into each of these tabs in their own specialized tutorials. This concludes the introductory tutorial to Vespa analysis, and I hope to see you in the next tutorial, where we'll take a deeper look at some of the features both in the spectral tab and in the fitting tab.